Welcome, everybody, to the American Space Museum. I'm Mark Marquette. We're so glad that we're with this guy today, Gary Allgire, to stay curious about everything you wanted to know about STS-1 but didn't know enough about it to ask, I guess. Gary,
Yes,
how are you, my
I'm
friend?
doing just fine, Mark. And
Good to have you here.
I like your new studio.
Well, good. Thank you. He doesn't like my mess around my desk, but we're going
Yeah.
to get that sorted out here after hours. And some of you will be seeing our new studio as you invade Titusville for Shuttle Fest this weekend. We're looking forward to so many of you coming here and seeing our museum for the first time, and then a whole bunch of you on a return trip. So, Marty Winkle's on the board over there. What do you want me to do, Marty?
Increase the gain on the mic.
Push the gain on the mic. Okay, so the gain. That's the volume. And I'm going to go over here and we're going to push a lot of gain there. There you go. Does my voice sound better on there? My silver voice of the voice of Stay Curious here. So we're fine tuning some stuff here in our little studio. Like I said, can't wait some of you to all come. And what you don't know about Shuttle Fest right now, please don't fret. You're coming to it. It's sold out. Everything will be fine, okay? And we are a little handicapped and some solid volunteers that know things that can help me, like word processing, publisher, stuff like that. So we're doing the best we can, but we're going to have a great time. And Gary, you're coming, aren't you?
Yes, I'll be there.
Great. Well, epic. What do you think about the anticipation here a week out? 4 great astronauts, a whole bunch of great people coming.
All I know is you're under a lot of stress putting this all together, and I'm sure it's going to work out fine, and it's going to be a great show.
Thank you, sir. Thank you very much. I know how to manage the stress a little bit, but the older you get, the more you got to eliminate it. So, more stress about things I can't control, like the tent that we're investing in. Gary, you get a bunch of space geeks together in a room and just throw out a subject and off you go, right?
Yep, that's what you do.
Which is, we're going to have a great subject today, how STS-1, Orbital Vehicle 102, Columbia, came here in pieces and parts and had to be rebuilt in many ways here. So Gary's going to tell us all about that. The beautiful shuttles of the month of April. 16 of them, 95 different tickets punched to space, and the one right in the middle. And Marty, you probably want to move that in between us there when you can. The middle one is, of course, the one we're going to talk about today, things that I don't even know about, STS-1, and that is this beautiful mission, one of the boldest test flights of any American
Yeah, it's true.
craft, right?
Right, it's right, because it's the first time we will launch something for the first time. Usually we launch them unmanned before we put humans in them, and this was the first time we actually had an astronaut on board for the very first launch.
Why do you think that decision was made when they could have flown it uncrewed?
Well, that was a result of the astronauts back, Dick who was here the other day talking about the things that the Air Force wanted when they signed on to buy the shuttles. And Dick Burt was
Dick
here.
Burt, yeah.
And he talked to two
Burt
of them.
Dick, we got it
Burt
backwards.
Dick.
Burt
Yeah,
Dick.
that's my problem.
Burt
Burt
Dick, yes, our
And
National Space Society friend.
he talked about how they drove the size of the payload bay, and they also drove the design of the wings. But the other third requirement that they wanted was they wanted to fly a shuttle with no astronauts in it. And the capability was there. That was how they first initiated the shuttle would fly, since it was just going to be delivering payloads into orbit. But the astronauts found out about it, and so what they did is they drove to have one of the systems taken out of the automatic landing system or launch system, and required that an astronaut always be on board. And
Is that when the pilot pushes the button to lower the...
it's the lowering of the landing gear. Yes.
Wow,
We'll
and
talk-
like 5 seconds before landing.
Well, at 1,000 feet altitude, he arms it. It's the shuttle pilot, it's not the commander. The shuttle pilot's his only job during re-entry is to do this 2-position switch. One was to arm it at 10,000 feet, and at 300 feet, when they do the flare, is when he pushes it and lowers it. And it's gravity dropped, And so, and it's worked every time, but that required an astronaut to be on board. Otherwise, they could have always launched it like the Russians did it without anybody on it. So,
They're a
and,
Buran one and
and
done.
basically it was a downfall to the shuttle because at the end they said, why are we putting humans on board to launch commercial satellites? And so that was the fault of agreeing with the astronauts to put himself on board.
Well, there you go. Right out of the chute, you get the flavor, you newcomers.
Yeah.
What Gary's going to be talking about today. Just let's give a shout out there to Dave Stange, new grandpa in sunny but cold Macomb, Michigan. Mark Thell. He noticed that we switched spots. Thank you. I'm on the right side here. Bob Mayran. Steve Jokums is chiming in there. Thank you, Steve, so much. Mitch Rothman of Man Space. Great to see Gary again. Always an interesting show with him. Mark Thiel. Yes, sir. He's sold out. I could shoehorn a few more in, but with all my volunteers and complimentary guests, we're going to have a good 135 to 50 people there at times. So Julie Clay, she's going to be at Shuttle Fest, and Carlton Bailey and Gary Gerald on there. And so I'll be taking any questions you have for Gary. I'm sure he's going to answer all of them, maybe in his talk along the way. But as we look at this beautiful image taken of it's a Milky Way put behind an orbiter, and I don't see the chine on it.
Well, this
chine.
is probably Challenger.
Yeah.
Because this picture came out very early in the program. It was very popular for us. It worked out there. Grab a copy of that.
This is the official insignia of the first Space Shuttle Orbital Test Flight, STS-1. The sphere of the Earth is in the background. The triangle of bright color ranging from red to yellow symbolizes the blast of the engines. An orbital oval surrounds the Earth and represents the orbit of the Space Shuttle. The artwork was done by space artist Robert McCall. Very simple and stylized. Of course, John Young, the commander, he'd already been to the moon twice, once orbiting on Apollo 10 and then commander Apollo 16, and driving a rover on the moon with Charlie Duke. He, of course, has passed away 4 or 5 years ago. Born in San Diego, John Young was, but raised in Orlando, so our John Young Parkway is always in the news every morning for the delays or some
That's
crazy
right.
wreck that was on it there.
Yeah.
And of course, Bob Crippen, great friend of our museum. Bob is 87 years old, I believe. And I communicated with him about a year ago. Maybe he'll show up at Shuttle Fest.
That'd be great.
Because he knows about it. So,
And he's our center director for.
What do you got to say about Cripp? And John?
I never got to meet him. John was unique in the meetings that I was ever in there with him, and he didn't speak much, but when he did, everybody listened. And sometimes you would think that he was a little off key with his comments, but in reality, he was always correct.
Yeah, pretty clear and to the point, and just a great human being, and we miss him. He was so influential in safety on the shuttle in the last flights, and so, well, I'm going to turn it over to Gary, and he's going to tell me when to advance our slideshow here.
Go to the next one.
And we'll go to the next one there and kick right there. Kind of how it all started.
This is how it all started. This was the lifting bodies that NASA was experimenting with back in 1963 through 1975. They would drop these from the B-52s. And these were unpowered. Well, most of them were unpowered. They did eventually put power to them and then flew them without the B-52. But the famous thing that came out of that was on one of the missions. I'm trying to think when that one actually was. Is a gentleman by the name of Bruce Peterson was flying it, coming in for a landing at Dryden. When a helicopter flew across his path and caused a downwash that caused him to crash. And it's a very famous sequence of events when they recorded it. And when he lived through it, and then he had to go through multiple operations to make him whole again. And that's the basis for the $6 million man.
Is that the crash they show at the beginning?
That's the
of it?
crash that they show at the very beginning. So, and I happened to see Lee here at the Space Center.
Lee Majors,
the
star of that
when
show.
he was doing a filming of down in our operations control room building, and they were down in a high bay area filming a sequence, and I went down and actually watched them film one of the sequences for that particular TV show.
Was that pretty interesting?
Well, what was interesting is they would hand him a big sheet of yellow paper like this, and there'd be 2 lines on it in real big print. And that's all he had to remember to talk about. I said, I could do that.
Yeah.
But it was a very popular show back then.
Oh, did you have them Lee Majors looks back then, Gary?
No, not like him. He was tall and handsome, and I was short.
We do have a question out of the chute, Marty, on our Streamlabs board there, on our UCX microphone.
Yeah, Michael Bruno was asking, did young equipment ever express what they thought the odds of success were? I think Armstrong and Aldrin gave their mission 50%.
I've never heard about them or what they had predicted. John Young was a tough, I'm gung-ho, I'll do anything type of pilot. And Bob Crippen, I would think, was pretty close to doing the same thing. So they were very, very brave to go. And then, of course, they had a lot of experience in simulations, flying the shuttle trainer that would come in, and they would fly that. So, but other than that, no, I never heard anything. Of course, we don't have a day-to-day conversation or meeting with the astronauts as an engineer.
Mm-hmm. Well, let's get to the meat of this talk here about the first orbiter,
Now,
OV, orbital vehicle, and they all gave him tail numbers.
yeah, this is OV-102. Well, this is what they did is when the contract was let out, all the companies, aerospace companies in the United States bid on the contract. And Rockwell, or North American Rockwell at the time, when they bid on it, they put in a stipulation in there that if they won the contract, they would sub out to all the losing contractors a part of the shuttle. And so they did win the contract in 1972, and it was, like I said, it was awarded to North American Rockwell. And this is a breakdown of who built what on the shuttle. Basically, the mid-body was General Dynamics, and then the forward and aft fuselage with Rockwell International. The vertical stabilizer was, let's see what I got here, Fairchild. And then the wings were built by Grumman Aircraft Corporation, and the payload bay doors were built by Rockwell, but it was their Tulsa division. And some of the smaller parts, the landing gear, were made by some of the smaller contractors. And we're not going to talk about the SRBs or the tanks because that was not in our preview at the time. We just worked on the space shuttle itself, and then we had other groups that worked on the SRBs and the external tank.
Excellent.
This is, I really don't know. It could either be Enterprise or it could be Columbia. I'm going to say it's Columbia. This is in Palmdale, California, when they brought all the parts together to assemble the vehicle. And that was the first starting of the, let me read here. They started assembly in 1977 of the shuttle. And this was in Palmdale, California. The plant had 2 bays. They could build 2 shuttles side by side. And this was probably, if it's Columbia, then Enterprise would be the other one, or it could be OV-099, which will become Challenger. OV-099 was called an Iron Maiden. This was common practice in the aviation industry, is to build we call an Iron Maiden, which was structurally the same as the original vehicle, except this is the one that they would do the structural testing on. Now they have an option that NASA selected, was they would not test it to destruction itself. They would take it up to the maximum loading that the vehicle was supposed to be fly in, and because they felt maybe someday we might make it into a flight vehicle. Mm-hmm. And it was chosen over an Enterprise, because one of the big problems with the Enterprise is that Grumman when they sent the first set of wings. Now, Marty, you don't have to hear this. The wings were bent.
The wings were bent.
Yeah, they were not bent bad, but they were good enough for the ALT program, but they were not good for the shuttle program for reentry.
Now, something, Gary, I want to keep our watchers to keep in mind. All this structural stuff you see that as an engineer, structural engineer, you're an expert on, was made for the environment of outer space and weightlessness. So some of it didn't have the tensile strength that you could walk on it or step on here on Earth, correct?
No, that's not totally correct. The payload bay itself, as you can see, the ribs, the bottom of that rib is probably 3 feet off of the bottom skin of the orbiter. And what they do is they'll put a fabric, beta cloth material in between the bays to protect it from the sunlight and from the environment. And that's what we could not step on. Because if we stepped on it, we would just punch right on through and be down onto the deck of the belly of the ship. And I'll show pictures later what's down there that you don't want to step on. But this is basically the backbone. Now you'll see 2 white vertical lines coming down from the aft bulkhead where the OMS pods are, and those are called seal longerons. That is where everything is attached to. That's where your payload bay doors are attached to the sidewall, but it's just right above the seal longeron, and all the payloads will be attached to the seal longeron that we will begin flying in the following years. Now, when we started here at NASA, it was a big jump to going from the Apollo program and having a small capsule that we could crawl around in all day long, and going to something that was actually a size of a 737 Boeing 737 airplane that we are now going to have to start processing. And we had very, very little knowledge of the shuttle when it was first given the contract to Rockwell. And the only thing we had in our office was a model of that OPF structure that you see there today.
That's our model here at the museum
And
of
that
the
could have
orbital
been-
processing facility.
And that could have been the same model that was in our office. How many of those were made? And we just kind of drooled over that, and this is what our design engineering people who are designing the facilities for the shuttle, this is what they presented it to us. And so we had the model shop made a model of the orbiter. We would have that in there, and we would try to imagine how we were going to provide access to get in there and to work on the shuttle. The other big problem that we had, and this is quite strange, is that the gentleman in our office was assigned the facilities, and he was asked by our design engineering, do you want the shuttle to be back into the facility, or do you want it to be rolled into the facility? And John was his name, and John has had a hard time. He's a very smart man, but he could not make a decision right offhand. So he hauled around. One day it would be we'll roll it in, and one day we would back it in. And he would go out to over to Orlando to the airlines and talk to them about how they get their airplanes in the hangars. He'd talk to me because I was at up at Jacksonville in the Navy as a plane captain, and we had hangars. And he asked, well, how do you guys put them in there? I said, well, our planes are small, the hangars are big, we do both ways. So eventually, design engineers got fed up with him delaying this mission, this selection. So they automatically said, we're going to pull them into the bay. And that was the correct decision to make because of how we had to get to the main engines to remove them after each flight.
Again, looking at our model here, buried inside of that is the shuttle.
And the shuttle is
And I'm told you could be in this building and really not even realize you're in
I have
the
a picture of that. We'll
Alright,
be
good.
coming up. Now, one of the things that we did, it had the rolling bridges that you see up there. Was 2 that you could roll back and forth.
That's the
and-
payload bay there.
bay
of
there.
course.
And so we asked for them to put some kind of a platform that could be hydraulically or cably dropped down so we could get access from above without touching the payload bay. Let's go to the next slide. And this is what we ended up with, these 2 set of buckets that could be raised and lowered, and each rolling bridge had one of these. It helps us get additional access to the payload bay. And you can see how we've closed out those ribs with blankets. And there's actually divided into 13 bays. And this is where you see right down there in the very center is a keel fitting for one of the payloads, and that is in bay 10.
Right there.
Yeah, right there.
A10, so
Yeah.
12 and 13.
And 12 and 13 we could walk on because it was we call the wing box.
Interesting.
That ties the left hand and right hand wings together to make it a one complete wing.
Wow. Marty's got another question.
Yeah, Michael Bruno's asking, was much computer simulation for aerodynamics possible at the time, or was it mainly wind tunnel testing?
It was both. A lot of math models were used, and we found out a lot of the math models are incorrect compared to what really happens in the real world. And later on, we'll do a presentation about how we install the payloads in the payload bay, and that had a big impact on us on what the math model said would happen on orbit. In reality, it never came to fruition.
Good question, Michael. Thank you. Let's go to the.
This is another model that we had to come up with, which is called the mate devices. Again, John was in charge of this. 2 were initially built. 1 was out at Dryden, 2 and 1 here at Kennedy Space Center. By the way, the first thing that was ever built for the shuttle was the shuttle runway. That was the first thing we actually.
That's a trivia question, Marty.
That was the very first thing. And then after we launched Skylab, the Skylab itself, Skylab 1, after it was launched, then we started decommissioning 39A and starting to configure it for the shuttle missions, which was back in 1970, 71, somewhere in there.
So follow-up question, if they built the runway first, were they thinking that there would be the 2 spacecraft, one be like the jet that would carry,
No.
that wouldn't be launched like a rocket, but like an airplane to begin with?
No, by this time we have already settled in on the configuration of the shuttle. It ended up, for a while there, they were really wanting to put jet engines on the shuttle. They would sling one engine under each wing. And there was people assigned here in our office.
There's the blueprint for it.
Oh, really?
It's my screensaver,
Oh,
yeah.
okay. And it ended up, we kept saying, that's a lot of wasted weight to put up in the orbit just so you could fly around once you're in the atmosphere. And then also, how are you going to control and contain the jet fuel that you're going to be loading on that vehicle so it could fly? And based on what we saw at the very beginning on the lifting bodies, they realized that they could do the same thing as a lifting body, and they would manage the energy as they re-enter, and then it could land it without any engines. So that saved a lot of weight, and it saved a lot of difficulty that we would have to do to process it.
I'll post them pictures one day I have off of a blueprint that John Tribe had for a while of the engines on the shuttle as they were proposed, just on, like a conventional airplane. All right, we're talking with Gary Allgire here, structural engineer with NASA. He's telling us
Before
about.
we go too far, one of the things as we talk about going from Apollo to shuttle, there was quite a bit of time frame from 1979 when we flew, or 1975 when we finished ASTP. Rockwell had pretty well, as we launched the Skylabs, they had pretty much gutted their engineering groups. They only kept 2 together, and that was the mechanical structures group that I was with, working with those guys, and I think the environmental control system guys were kept. All the other systems were either laid off or sent back to California. So we're pretty much on our own here at NASA from an engineering standpoint on ourselves. So when the time came, what NASA had to do is we had 2 major organizations that we had to do something with. One was the launch vehicle, and the other was spacecraft. So what NASA decided to do was to take all those people that worked in those 2, put them together. We had a room where everybody's name was written up on the wall on sticky pad. And what they were going to do is bring those together, and then we will separate those into two different groups, which we call shuttle and one we call payloads. And you're familiar with the payload guys, the level 4s, 2s, and 1s, and so forth. So you didn't know where you were going to go work. And it was very stressful for a few people. They really worried. And this went on for a year before they actually made the announcement who was going to be working where. And so there's a time frame where you don't know exactly for sure what you're going to be doing. I was assigned the shuttle, but that didn't mean that I would be working shuttle. I could be working payloads. You didn't know. There was no way to talk to anybody because they were very tight-lipped on this. Now, what they finally made the announcement, and we're going to come out within the next 30 days, and we will tell you where you work. Well, somebody in NASA went into the room next to the room that's locked up with all his tags on the wall, moved the desk over to the wall, put a chair on it, got on top of it, lifted the ceiling tile, and then lifted the ceiling tile of the room that they was going to look in there, had a flashlight, and he caught 12 names at the most, and he came out and he announced those names. And management got totally upset and delayed that reorganization for another 3 months. And so everybody was mad.
Engineers don't like to know
No.
what
They wanna know-
uncertainty. Yeah, that's great story, Gary. We got another question from you viewers,
Before I
Marty.
get to the question, but that was just on the NASA side,
Yes, that was NASA side.
right? Not on contractor.
Okay. Now, so for the contractor side, when everything was all settled and done, I went up to what used to be my engineering office that I worked with, the rock contractor, and I walked in there, and there was not one familiar face in that group. They hired all new engineers out of college, and they had hired one guy that was older, and he was a lifesaver because all these new engineers, and they knew nothing. So it was my responsibility kind of to go in there and start saying, this is how we did business in Apollo. This is how we're doing business, and what changes we're going to make because we go from Apollo to shuttle. And so I had to educate all those guys, besides also learn how to work on the shuttle.
We'll interject here that Marty also at this same time frame was segueing from the lunar module of Grumman to the launch process services. Marty, you were involved, so he knows a lot about this transition here. We'll get going here. You got a lot of slides ahead of us here to show. We got another comment or question.
Yeah, Tom Colbert is asking, airlocks were moved from mid-deck to the payload bay for the Mir and the ISS flights. Why were they built in the mid-deck in the first place?
The Columbia came with its airlock in the mid deck, and it was designed so that it could be taken out and put into the payload bay. They just had a big door. It'll be in this next presentation that I don't have it in here. There was a big door that they could pull off on the aft bulkhead of the crew compartment, and then they could go in and grab the airlock, bring it out, put the door back on it, and then turn the airlock around and bolt it to that one. That gave them a little extra room inside the crew compartment, and Columbia always kept it inside because what you do is you're taking your 60-foot payload bay and you diminished it by about 10 to 15 feet, so you cannot put a full-length payload in there like sometimes we were required to do. So that was why we did it. Now, when we got ready to, after Columbia's accident, then we were going to strictly use it to go to the space station. Then the Endeavour and Atlantis and Discovery, all their airlocks were put on permanently outside.
Good question. Good question. Now you know.
This is the difference between Columbia and the rest of the shuttle vehicles. Now, Columbia was actually heaviest of all the vehicles. And this is one of the reasons why is because of the ejection seat. But Columbia weighed 179,900 pounds when it was delivered here at Kennedy Space Center. It was 2,200 pounds heavier than Challenger, and it was almost 9,000 pounds heavier than Endeavour, the last vehicle. So this was used for the first 4 flights. It was the injection seats. They had blowout panels above the astronauts, so when they pulled the injection handle, the panels would be blown off, and they would eject it out of the shuttle. Now, they could not use these while they were still on the solid rocket motor engines. There was just absolutely no way that they could actually do that. So they had to wait basically for re-entry to reuse those for wherever they aborted from. Eventually, once we started flying more than 2 astronauts, then we de-armed them so that they could not be used. And we used those in there, stayed in here until we sent it back to Palmdale later to have a large going through the arbiter to get it as light as we could, which means taking all the ejection seats out. The blowout panels were removed, and then we tried to take out a lot of the instrumentation that was dedicated to the shuttle. This is a picture of the actual ejection seats. This is the commander's seat right here.
They were modeled after an aircraft.
The X-15
Okay.
was what they used because of the high performance of the X-15.
Not the SR-71.
No, it was X-15.
Okay.
I think that's what they used. This is we started out with 2 orbital processing facilities. We have Bay 1 and then Bay 2. Bay 1 was the eastern one, and Bay 2 was a western facing one.
These are around the vehicle assembly building
yeah,
when you go out
They're
to
to
the center.
they're to the west of the and south of the north of the vehicle assembly building. We ended up with 3 eventually because we had 3 orbiters here at one time. Bay 1 was the only one we used for almost all the first years of missions between Challenger and Columbia. In front of the building was an engineering offices, and also the scheduling room was in there. And you went in between the 2 buildings, and we'd go to a station where we turned our badges in, so we're going to go inside to the payload bay. And what was interesting for the STS-1 is we, because of the tile, it came with us with almost what, let me wrote the number down here so I don't forget, make sure it's correct. It came with 32,000 tiles, of which several of them fell off during the transfer over. Then eventually it was reduced to 23,300 tiles. But it had the most tiles of any of the shuttles. But we had to bring an extra set of crews down here from Palmdale, California to assist the tile people that we had. And what they found out was one of the weirdest things is once you turned your badge in at the badging station, there was 2 doors, an indoor and an outdoor. And what they found is after a while, the hinges were being wore out.
Oh my gosh.
And we replaced those during that STS-1 flow. We replaced the hinges 3 times. They put a security guard on the door with a counter. And when he counted them, they were shocked at the high number. It's almost 1 a second going through those doors. People going in and out, taking materials, working, doing whatever. So that was a very high activity flow versus any of the other ones that came past that.
Had
But
replaced the
I
hinges.
did circle back there on the south side of the door. And that is a door right there that's opened up. That's where we bring in the canister and the strong backs to put payloads into the payload bay while we're in the horizontal position.
Oh, okay.
And then there's another little small door. It's blacked out. That is for the tow tractor to when it lands from orbit on the runway, they hook a tow tractor to it, and then they'll pull it into the orbiter. And so to get out from that, he has to go out through that door once they've positioned it properly into the OPF.
And there's an orbiter being pulled in. I know it's not Columbia because you don't see the black
Right.
on the chines right there.
And I think it's on a transporter.
okay.
It may be rolling out.
That's a cool picture there.
It may be backed out and rolling. It's going to go over to the VAB where it will be mated to the external tank. This is a tail cone being put on out at Dryden Air Force Base, Dryden Research Center, excuse me. The tail cone was developed and built by Boeing Aircraft Corporation up in Seattle, Washington. I did go out there for the sign off on it to say that yes, we accept the tail cone, and we got a little bit of a demonstration of how it was put together. Boeing was very proud of something that they developed. You see the hump there? that goes from the left all the way down to the tail end at the right.
Yes,
They what they did, instead of making two tooling jigs to build two, a left hand and a right hand, they came up with a procedure where they could just build one side and to build another one on the same side, and they could flip it inside out to make it a left hand and a right hand.
Hmm.
And it saved them quite a bit of money in manufacturing of that.
interesting, very interesting. What would be that black hose coming out of there?
That's an air hose to go in and provide air while you're going in there, and you're
Working
connecting
on
it. You're connecting it to the orbiter itself.
Okay.
It's 4 bolts. That
And the tail cone under the engines was necessary because?
tail cone under the engines. No, the body flap was underneath the engines. The
No,
tail
no.
cone-
Why the tail cone? I'm trying
that
to
was-
give an elementary
okay.
question to those that don't
That was
know
for
why that was
aerodynamic flow.
aerodynamics.
Yeah, because the buffeting coming off, if it didn't have a tail cone, could actually vibrate the elevon, the rudders, and cause them stress, and they could fall off. So the smooth airflow across that surfaces, and also give them better control, which what had the tail cone. Now I think for the drop test, the first several of them we had the tail cone on, and then we finally took the tail cone off, and just for that sort of flight that they could do that. Now for going across country, they had to have a tail cone on.
Okay.
This is the Bay 3. This
It is Columbia, as
Yes,
you note the black right there, the
that's
sides
Columbia.
there.
It's going in there. This is after Challenger. It was pulled into the building. They opened up the payload bay doors, and they removed every single blanket of insulation in that vehicle and put them in, we don't know where, all over. And they were going to work on it to remove some more instrumentation if they could. I don't think we did much work. Now, what's interesting is, I don't know if it shows up on here. If you see the red markings there,
Mm-hmm.
you'll see 3 yellow lines.
See them, yes.
Okay.
About right there.
Now, and there's
Right
3
there.
yellow lines that on the other side. John again had an issue. Is that we know is from putting planes in hangars that they have a line that the plane will follow, go through a curve to get into the building. And John talked to me about it. And he says, "This is they do this." I said, "Yes, they do." Well, he wanted a line for all 6 tires.
I see right there on the concrete
Yeah.
in the back the yellow
Yes,
lines
there's
there.
six lines.
Oh yeah.
And I said, "John, you don't need that." I said, "Wherever the nose is going to go, your main gear is going to follow. You don't need them." Well, he didn't agree with me, and I kind of dropped the ball. I mean, I didn't say anything more to him because there was no use arguing with him, and he got his way. So you'll see all these lines now. You asked a question several years ago, about a picture of the OPFs, whether it was taken after the shuttle program or during the shuttle program. And I could tell right away that it was taken after the shuttle program, because all of those lines had been erased.
Oh,
Okay,
okay.
all right. And now, so it's being rolled in.
We're talking these yellow lines that you see in the back of
Yeah.
the engines there, and then going into the OPF. Of course, you got the stabilizer. They cut a hole out there for it.
Everything has to be aligned perfectly to go in, and I'll get to this here in the next couple of slides. This is probably getting ready to roll out to go to the VAB to be mated to the tank. You'll see a gentleman standing in front of the shuttle. He's got a flashlight in his hand, and he's showing something so that he can tell the operator in the cab if he's going straight or not. And let's go to the next slide. And this slide here, you're in the way, but I did blow it up, and there's a pointer now you're covered up even more. Let's go to the next slide.
There it is.
Yeah.
You
He's
see
shining a light on that, and this is telling the guide. Now, if you go to the next,
the arrow right there.
yeah, there's an arrow pointing to it. This is a close-up of it. Now, between those 2 large yellow lines, John also had a small line that was 1 inch wide. That was the most important one, because that was what we aligned the shuttle going into the OPF.
John's last name again?
Fraley.
Fraley.
He's
Look at
passed
this. This looks like a part of a golf cart or something.
Well, or one of these guys that goes around measuring things, so
yeah,
forth.
right. Yeah.
And so he's talking and telling this guy that's in the cab, "You're on the line. They use it also when they come in with the tow tractor, or they use it with if they bring it in on that transporter.
there.
Yeah. And so that aligns everything perfectly. So we have 4 jacks that we're going to jack up the orbiter off the ground, so we can raise and lower the landing gear for testing. This is a picture of the nose wheel landing system, and up there at the very top, I have a circle around an area, and there's also let's see, let me get in here so I can see it on mine. Looks like an open inch wrench that has been cut off. There's 2 of them. And what that is, they're just right below that circle. Go back here. And what that is since it's gravity, it's hydraulically retracted, but it's gravity dropped when they're landing. And what they do is we'll raise it hydraulically, and that's the cylinder will engage those 2 clamps. And when it does, that will pull the payload bay doors closed. I mean, the landing gear doors closed. Now, Terry White always talks about we have to push on the doors to get it to finally close.
The broom crew.
The broom crew. The reason why they're doing that is because, let's go back to the next, let's go to the next one. Not this one, come back one more. Up here, I don't think it's going to show up. Up at the very top of the white circle.
Oh, gotcha.
Okay.
Way top.
There's a black looking thing is sticking down.
Yes.
That is a spring-loaded thruster. And so when they close, the hydraulics are not strong enough to compress that also. So that's why they push on the broom crew pushes on that door to make it close all completely. And then if you go down, see, can we get, yeah, down there where I've circled it, that's where that plunger touches the
black piece
now,
right up there at the top.
When I was at design reviews out at Downey, the engineers talked about, they were concerned because it's gravity drop. The main gear was not a problem because they're so heavy. The gravity is going to make them come down. The nose wheel was light, and they were kind of afraid because of the high speed that they're coming in at, that the airflow across there would keep the doors from opening up right away.
200 miles an hour.
Yeah. And so what they did is they put a plunger in there. They talked about a plunger or using ordnance, and plunger was what they selected to do. So that's why we really push on that.
Very interesting. Wow.
Yeah.
Kind of simple technology for such a sophisticated vehicle.
Yes, save some weight. Now this is what you talked about when you walked into the OPF, and this is what you saw. Inside there is a shuttle, and there was no way to ever see it because of all the people and all the equipment that was surrounding it to service it. Now to open the payload bay doors in the horizontal, they're graphite epoxy, but unfortunately the motors that are used to drive the doors open are designed for on orbit in a weightless environment. So they were not strong enough to open and close the doors in a horizontal position. So we put these things called strongbacks on them. They each had these little, we call C hooks on them, but they're just like a portion of a C. And at the very tip of it is a cable that ran up into those rolling bridges and over to a weight cages. And that was what that would counteract the weight of the door so that the actual flight door motors could open and close the doors. And this is the doors in the fully open position that we would see for flight. You can see the hooks, how they have come around, and they're right above that. These are radiators that you see. Radiators are 1-inch thick aluminum there's 4 panels. They're independent of each other on each side of the vehicle. The front 2 were considered to be deployable because they had radiator disposition from the top and from the bottom. And what they did, it's just a 1 thick sheet of aluminum honeycomb. And what they would do is they would go down a line, they would kind of increase it, and then they would lay a tube on it, and would lay tubes there. And you can see the tubes in here because those are little white lines that you see running around. And then they would put the outer sheet of aluminum on top of it. They would press it together and glue it together like that. and they did it on both sides. Now the aft two only had it on the top side, and they were not deployable. Originally, we were only to fly the back two radiators only if we had a high energy consumption flight. But they ended up deciding to just leave them on there because, one, the astronauts did not want to deploy the radiators because that was something that if it didn't work and they had to come back in on an emergency, they had to go EVA, cut some linkages, and let them fold down. And so they didn't want to do that. So as far as I know, other than Columbia's last flight, those radiators were never, ever deployed
Really?
in flight.
And you can look at pictures to see if they've been deployed. And you told me that, and I don't see any. But you say 107 had them deployed?
Had one. They had the left-hand one where they suspected they had the penetration into the RCC.
Mhm.
But anyway, if you got real close to these radiators, they were 95% efficient, as we call emissivity and reflectivity. Emissivity is the ability to eject the heat into space. Reflectivity is to take the sun's rays and bounce them back without ever absorbing any heat into them. And if you got real close to these things, look, and you got down about this far and looked at them, what you saw was aluminum tape, is aluminum tape, but it had all these little bitty bubbles of aluminum on that thing. And that's what, and then they coated that with Teflon, and that was how they were made. And we were told by the designers that we had to use atomic devices to do away with the negative, because it said static electricity will build up on it, and we had to do that. We never did. And we were told never to wipe them down with any cloth, but they did. I tried to stop that, but it didn't do any good. They cleaned them every
Very
time.
interesting.
Yeah.
The shuttle, computers, equipment generate a lot of heat. If the shuttle doors wouldn't get open at first orbit,
And they don't. Then they have to come back.
because it'd get too hot inside.
Yeah, they
things would start failing.
lose the electronics would overheat and they would start failing. So we don't want to do. The other thing which was unique about this compared to Mercury, Gemini, and Apollo is we're now flying 14.7 cabin pressure, dual atmosphere like the Russians were doing. And the thing why we had an airlock voice on board is that we were told is if we exposed the crew compartment to a vacuum, all the electronics would fail because they were not designed to be operated in a vacuum. They were designed for 14.7.
Interesting.
So that's why we had the airlock.
Huh.
Again.
All right.
Now over here, go back to that back picture. Again, this is a little bit hard. Let me see what mine shows here. Talk about. Let's see. What we got here? Oh, I got that. Let's see. We got this picture.
Mm-hmm.
Yeah, let's go to the next picture. This is the in the aft end. This is where the engines are going to be put into the vehicle. You can see the vertical stabilizer there. I'm not sure what vehicle this is.
Out at Downey, right?
No, this is here at the KSC.
Oh, really?
Yeah. And then the next picture shows how we put them in. And unfortunately, you're in the way. There's this big machine that has this guy sitting up on top, another guy off to the left of him that's controlling this thing, and they drive it in, and they will install it into. You can see the people inside the opening for the main engine. This is how we remove them and install them after every flight. And again, this is inside the aft fuselage. These are covers. You'll see these are the fuel tanks. Maybe Marty can explain which ones they are.
But that is a what?
One's an oxidizer.
18-inch big.
At least 18 inches, 20 inches. They're pretty good size. One of them has a cover over it. I went inside, I think maybe once or twice, just to say I was in there, and then we were looking at some other little problem that they were asked to go look at. But that's it. But
into the bowels of a space shuttle engine
yeah,
compartment.
And then everything. This was a challenge. This is the OMS pods, which I didn't mention was made by McDonnell Aircraft Corporation. This is the fixture. John worked pretty hard on this to get this thing to design because it actually was not a simple removal. We had to. It's on a slope. We had to be able to not only lift it, but we had to rotate it up out of vertically and then lift it off the vehicle. And he was pretty proud of this, that he was able to get this and it worked as good as it did. And
The
these
OMS
were
pods
taken-
are the big engines in the back that now that's the only big thruster engine.
No, these are the reaction control engines. These
Yeah.
are for pitch rolling and
Right,
yaw.
yeah. The 3 engines in the back are worthless now. These are the
Yeah,
ones
there are
that,
3 engines back.
yeah.
There's 5 engines on the aft fuselage. The 3 big ones are your SSMEs to get you into orbit, and then there's 2 smaller ones that are used to actually put them in orbit and also to deorbit them.
and that's what the OMS pods are the.
And, well, the
fuel.
OMS pods was not part of that. I mean, the fuel was. And if you go to the next slide, you'll see.
Marty's got a question there. Well,
Yeah, before I give you the question, move the mic closer to Gary.
Well, I guess I should pull it.
okay.
Getting some comments
There we
about
go.
his volume's low, which I knew was a little bit low. Anyway, got a question from, where'd it go? Give me a second.
Dean Babcock.
Oh, we have one before that. Michael Bruno. When the shuttle is on a 747, I assume it contributes lift, or does the 747 actually do most of the work?
747 is going to do all the work. It may got a little bit. One of the surprising things with us is if they had actually gone over and landed over in Saragossa, Spain, or one of the TAL sites, is that if there was a payload still in the vehicle, they had to have it removed at the landing site because they had to get the shuttle back across the Atlantic. They couldn't put all the fuel on board if the payload was in there. So to put maximum amount of fuel so they could get across,
Wow.
they had to have the shuttle totally empty.
That would be an amazing thing if
Yeah.
it had ended up
Yeah.
in Saragossa or
And the other amazing
Banjul.
thing after I mean, this was back probably in 2019, 2018, they realized that if it had landed overseas on one of the TAL sites and they had to remove the payload, they could not do it out in the open. So the gentleman in our office at the time was responsible for procuring a tent to put over the whole vehicle.
An inflatable tent of
An
some
inflatable tent. And so what they did is they found a contractor in Canada that makes the tents for the big circuses. And so they contracted to NASA to build one of those.
sort.
And so they built this huge tent, and he went up there for the receiving inspection, saw it assembled, walked inside, said, "This is great." And then they folded it all up, they sent it to KSC, and we never ever used it. And I have no idea where it was at.
Yeah, that's an interesting story. We'll follow up with that with Dean Schaff, who is the
Yeah.
ground office manager
Yeah.
of the transoceanic abort
Yeah.
landing sites. Marty, go ahead.
Yeah, Dean Babcock is asking, could the engines have been removed at the launch pad?
Let's see. I'm trying to think. I think we may have moved one at the pad.
No, they've been removed from there. We talked about it the
Okay.
other day.
Yeah.
Right, Marty? We talked
Yeah.
about the engines were removed
Okay. At the pad.
on one of the shuttles of April.
Yeah.
On
Okay.
there. So yes, they could do that. Probably not as desirable, but
No, it's probably true. I know for STS-1, we did an extra, we went out to the pad and the engine guys wanted to go ahead and test fire it before we actually did light them off for the first time, even though they were proven to be reliable to do that. But for the first 4 missions, we always operated, ran the engines before we launched.
mm-hmm. All right, just a reminder to keep our outdoor voices going
Okay.
here. And Gary's doing a great job today, as always. Gary, what are we looking at here as we're
This is the
talking about
backside of the OMS pod.
OV-102 Columbia
This is the backside. This is your oxidizer and fuel tanks.
of the OMS pod?
On the OMS pods, the smaller ones that you see there are nitrogen tanks to purge, not to purge, but to put pressure on the tank itself so that they would always have a positive flow to the engines. Because they didn't want to do it. In Apollo, we call it an ullage maneuver, where it's mainly for the main engine, where we would burp the RCS engines to give it a forward G and
Yeah.
it would cause the fuel to compress onto
Sloshing the fuel back where
backwards. Yeah.
the intake
Yeah.
port was.
And the red engine bell you see there, that is the ones that they're used for deorbiting or putting them in the final orbit of the vehicle. This is Columbia back when it first got here. We still don't have all the blankets on the aft flight deck bulkhead of the crew compartment. Off to the left and up on the left corner, you'll see a yellow structure, and because it came without the radiators on the left side of the here. And so what we did was we had to put those on, and that's the strong backs that supported the radiators when we put them on. And you can see how different configuration of platforms we use to get us access. You see guys down below the blanket line. See
Oh,
them
right. Yeah, a guy in a white shirt.
Yeah, the white shirt. We have a photographer taking some pictures. We have some of the cable trays exposed. And of course, we don't have a lot of the blankets off. Okay, I gotta talk louder. I'm trying to. And so this is Challenger. Now we could get into the payload bay without going through the crew compartment and through the airlock. On all the shuttles, and starting in bay 2, there was a door that was opened up underneath, and it was above the wing and below the radiator, the doors when it was open, and we could crawl through there, and that's where we would start putting platforms in. We'd put the platform in at bay first, and then we'd go forward with it up to bay 1, and then we would work our way down all the way to bay 13, putting these platforms in, and we reversed that as we came out to roll over to the VAB.
Well, I'm enjoying this. I hope you all are taking into the bowels of our orbiters and see things that you're not familiar with. Look, like you said, there's a guy right there. Yeah, right there. Another photographer,
And,
so forth.
and before you go back, you'll see the 2 arrows I pointed out here. They have not installed we call air ducts that are there to provide an air shower to the payloads while we're horizontal and vertically. And there's 4 or 5 attach points. They're little black squares, and I just pointed out the 2 top ones. And if we go to the next slide, you will see them installed. And you see those tubes right there? They're flexible tubes, and we would use that as an air shower that always continually flowed while we're in the OPF or out at the pad.
It sounds like the place was a little noisy.
Very noisy. Yes, there was a lot going on. And this is what Columbia looked like underneath the blankets. Now you see some red RTV between the channels that run longitudinally along the ship. And this is where we had riveted these outer skins to those devices. Now it came to from Palmdale with some of them already coated. And what it ended up doing, they were worried about a burn through for STS-1. So we had to go back in and put more of that stuff in all the different channels that did not have them at the time, which was a labor-intensive object. You see the tubings for fluids in there, and you'll see some electronics. Again, underneath your head there is a torque tube. I mean, a boron aluminum tube. This is what we use to manufacture, to assemble these frames. Boron aluminum was actually the strongest material that we could man-made that would support the tension and compression loads that the orbiter would see. They were stronger than Inconel, stainless steel, aluminum, any of those materials. And reason why we used them is for weight savings. For every ship that was built, a ship set was saved 550 pounds over any other material that we could use. They were very fragile though. They were good in tension and in compression, but you could go up there and put your hand on it and push on it and you would fracture it. It would split like bamboo. And eventually, I think over the program release pace, while I was in engineering, we replaced 2 of them. And they're difficult to replace because they could be under tension or they could be under compression, depending on what day you pull the pins out. And then you would have to go in there and start raising gear to see if we could get the 2 to match up again. Or getting people out of the vehicle. So it was a challenge to put those back in.
Fascinating stuff about our orbiters here. Marty, you've got questions and some follows up on those engines.
Okay, got a question from Dean Babcock. Then I'm going to read a comment from Carlton and Steve Holcomb, which, by the way, what they're saying is accurate. Before I even read the question, Mark, let's go ahead and invite Kevin Hostrap, so one of our Stay Curious. Kevin was
Let's go ahead and what?
invite Kevin Hostratzer.
Oh, yeah, we'll
He was
get Kevin
involved in
back
the
here.
engine removal.
And
Anyway,
I'm sure Terry White can answer these questions
No, Terry
too.
would have nothing to do with the engine.
Yeah.
Okay.
He's strictly the OPF.
And Terry White, I don't know, he wasn't, the person that was in charge of the OPFs was Randy, so what was Randy's last name? I want to say Randy Vera, but that's the wrong person.
Kevin Hofstadter, he's mentioned, has been on here before and had a model of an engine,
Randy
the
Rooker.
SSME engine that he talked about.
Yeah, okay.
Randy who?
Randy Rooker was in charge of the OPF base. He was the lead for all the techs, and he was the man that you went to. Terry White came on after Randy Rooker, from what I believe, because Randy unfortunately had a heart issue. He quit taking his medicine and he passed away about a month, 2 months after quit taking his
Oh
heart
my.
medicine. And it affected everybody out there.
Huh.
Everybody loved that man.
Funny, Mark, the question that Dean's asking, what would have been the process used to remove the SSMEs? And Carlton indicated that special platforms had to be installed. And Steve Holcomb says Carlton is right. Special scaffolding placed into the flame bucket. The engine's fixture was jacked up to hold the engine and lower it out of the aft. But again, Kevin, give us more detail.
Okay.
All right. Now
All right. Thank you all for your input there.
the next slide is a blow up of that previous one. And what it shows is you'll see some wires running into that RTV, and there's a temperature sensor buried in there. And so there was a rack in Columbia that had carried all the recorders for all the instrumentations for thermal readings. We had G load readings and accelerations and temperature monitoring. And it was quite a bit of instrumentation that was put in there, measured stress and so forth during the first development phases of the shuttle.
All of it paid off,
Yeah.
trimming off 2 tons, you said 9,000 pounds,
Yeah.
which should be almost 5 tons off of Endeavor,
Well,
Enterprise.
Off of
Endeavor, off
off
of
of
Endeavor,
yeah.
you said, yeah.
They had
Endeavor.
lighter because by then they figured out a lot. We didn't need probably all the RTV in there, thanks to we'll talk about later about the silts pod. This again is just showing the amount of wiring that's in the shuttle bay. Both this is could be not can tell which direction we're talking to, but this could be the right hand side or the left hand side. They're identical. The upper tray and the lower tray are dedicated to the shuttle itself, and they run from the aft compartment to the forward fuselage. The center tray, which is a smaller one, is dedicated for the payloads. So each payload that comes to be installed in the OPF or out at the pad, basically at the OPF, they will bring us their wire harnesses or any of their fluid lines, and we would have the responsibility to install them. And then when they install the payload, no matter where it was at, we hooked up the connectors, and then we turned it over to the payload community to do some testing. And after we came back from the mission, that was the first thing we did after we opened up the payload bay doors and got it safed. Then we would go in there and take the covers off the center tray and remove all their equipment to get prepared for the next payload that would be flying. Again, this is some more. One of the things we kind of like to point out, there's another picture, is we had a platform that we could put across to give us access anywhere we needed to at the SIL launcheron area. And then right below, you'll see we call a pick board that's actually suspended by ropes. And we had a crew called a high crew, not because of what they smoked, but the high crew. And they were responsible for providing us access to areas that we could not get to. These gentlemen were magicians. I mean, out at the pad especially. If I wanted in the middle of this room, I wanted a platform. suspended in the middle of this room, they would do it.
Huh.
They never failed. We challenged them quite a few times. They never failed to give us a platform using these pick boards and ropes.
See the ropes there on the left hand
Yeah.
side, and the boards are
Yeah.
the gray that you're
Yeah.
talking about, right?
And you see the venter. Here's another, here's a better selection that shows a pick board. They had various links
Right up there.
and tied up there to give us an access at that particular point that we didn't have a platform for.
Hmm.
And then this is a payload bay that's getting pretty well closed out. We still, underneath behind your head is one that's still open. The one that's in the center up here to your left is a keel fitting. They were active fittings that they actually electronically opened and closed for the payload. The keel fitting, which I'll talk about when we get to the payloads, what the purpose of that was. And then you see some of the boards, access boards that we had that we could walk on.
Mm-hmm.
Okay.
That should be removed there, the
Be
gray.
removed.
So
And
that was the attachment point for Space Hab, Space Lab.
Every payload
suspicious-
it was flown in there had one.
Uh-huh.
And I'll explain that, why we have those.
He's going to have a program on payloads next, or first we're going to talk about Apollo 13.
So it'll be a
next week.
follow-up. But go back again. You'll see some lights that are between you and me. There's a payload bay light that when they were on the
right.
dark side of the orbit, they could light them up
Right
so they
there.
could see the payloads. You'll see the center wire tree has we call pop-outs. Those where cables will come out. You can see some cables that are out. This is post-Columbia picture. And the reason I can tell you that is because it has two arms on it. We only have right now, they only have the right hand or starboard side arm on there, which is connected to the original arm. It's not on, but you can see the pedestals. It's been taken off for some reason, and it will be put back on later.
The two arms being the extension arm.
The extension
to,
arm, so they could look.
inspection.
So they could look at underneath the belly to see what tiles were missing. This was we called long poles. When we were getting ready to finally figure out, I think we're going to launch, we had to get out of the OPF, and there was 3 long poles that were driving the schedule. And the first one that you're seeing right here was the RCS leading panels. It originally came from Palmdale with fiberglass ones on it, and so we had to replace those with the original RCC panels. The panels and then also the structure they tied to were incompatible. We had a lot of problems with if things did not fit. So there was a lot of re-engineering during that first process of that first flow, and it seemed like it could be a long pole. The second long pole was we call the flipper doors or tail feathers, and that is the doors that close off between the elevons and the wing itself. It's a big opening about that big. You can't see me out there. About that big in there, and these panels that came over that were on hinges, and as the elevons came up, they would slide up on it to keep the area closed, or if as it went down, they would go out and they would keep that closed. And the rigging of those were very, very tough. The first time we tried to rig them, we had a special crew here dedicated to it. They spent 3 months trying to rig them. Never could get it done. So they decided to bring a crew from Palmdale down for 3 months to rig those. Again, they could not get them rigged properly. So they went back to Palmdale, and then the original crew came back and spent several months, and they finally did get them rigged. So that was the next to last long pole. And of course, the long pole was the tile.
The tile, yes.
Replacing and repulling on every single of
That
those.
caused the ultimate delays
Yeah.
there. Got a few more slides to show you here, but we got some great questions in the queue there. Marty, go
Dean-
ahead.
Yeah, Dean Babcock is asking, wait a minute. I keep getting additional comments. I gotta go back and find it. Oh, why was it determined to pull the engines at the pad? And
What was it?
why was it determined to pull the engines at the pad?
That's have to speak to an engine person, but I think they found an issue with one of the turbines in the vehicle or
No,
something.
they found cracks in the pipe,
Right?
in the fuel lines.
Oh, is that what it
during
was?
I think during a second FRF,
Okay,
which is a flight
flight readiness for
flight
firing.
readiness.
And yeah, so that would be the reason why they pulled them.
Okay, and then Dean's also asking, could vibration of the launch and reentry cause electrical shorts within the wiring trays? And that's electrical if you want me to answer that.
You want to answer it?
The way they bundle the cables, it's very unlikely that you're going to have any problems with the wiring. They're also sheathed, and I forget what they were sheathed in to give additional insulation.
They were wrapped and they were pretty well bundled up really good. And then after Challenger, NASA was they leveled a requirement on NASA, which our engineers kind of fought it for a little while, was to high pot every one of those wires after each mission, in which I guess they send down a high voltage down through each wire to see if they're still connected and there's no cracks in the wiring or anything like that. Over time, it actually degrades the wiring, but they were able to they would take that risk, and it added a lot of time to the turnaround time.
Well,
And,
we got to remember that Eileen Collins with the Chandra Observatory wiring was rubbed by a bolt and short circuited it. So yes, absolutely,
Yeah.
they did have a problem with the wiring, and that necessitated every
Well,
orbiter to be rewired. And I think I forget what mission that was,
I
but
don't recall him being rewired, but we also tested every wire anyway. Every circuit was always retested after flight.
okay. All right,
But
Marty,
I was
go ahead.
thinking the miles of wires in each orbiter and the number of missions. So it, how many problems do we have to the wiring? Very, very few.
We'll look into that.
It was, I tell you what, it was a lot less than it was in the Apollo program. We were always bending pins, and I don't recall all bending pins in the shuttle program.
Uh-huh.
That was a lesson learned that we did do better on.
We've got another question from Michael Bruno. Does there still exist a complete set of blueprints if the STS was ever desired to be rebuilt?
Well, I wouldn't use Columbia's blueprints, but there could be in a repository someplace. There could be that. I have a drawing that it's a very rare drawing that I'll talk about when we do the payloads. That I have the only copy that was ever brought to the Kennedy Space Center. It was illegal, but I used it daily.
Well, you did a Russian Buran program, very extensive, and look at that program Gary did about the Russian one and done shuttle, and they stole all the plans from the archives of our library in Washington,
Yes,
which
right.
were on there. So.
Steve Holcomb is saying that not NASA, but Rockwell, especially when they got sold to Boeing. So Rockwell or Boeing may have it.
I don't know. We had a copy. That's a complete set of drawings here at Kennedy Space Center that was kept in the headquarters building that we had access to, both in the Apollo program and the shuttle program. Because when we worked on the shuttle, we had to have an official drawing with us to do something. We could not use a photocopy. We could not use. We call a blue line. We had to have black line. We call black line drawings. We had to have the latest engineering orders that was associated with that program. So a lot of research was done by the Rockwell engineers and myself when we did something that we had to go do to make sure that we had the latest and greatest information to give to our technicians so they could do the thing.
Hopefully they do exist somewhere. So
now this is a silk pod. This was added later. This was an infrared sensing system that was look at the infrared signature of the leeward wing, which I think was the left-hand wing, to see what the temperatures came as the orbiter re-entered the atmosphere. The other thing was originally we were hoping that they would put a camera in there so we could have a video of the reentry, but they said they were going to, but they never did. It was used for several flights, and then it was decommissioned. But this allowed us to start reducing the number of tiles that go to frizzy. This is going in. This is being mated to. Will be mated to the external tank. I just want to show this. The wingspan was wider than the gap was for the opening between the high bays, so they had to rotate clockwise the orbiter to get it through the opening, and then they would rotate it back so they could mate to the external tank.
or Our facilities manager, Dan McCune, could be on that crane as he was a crane operator.
And when they brought Enterprise here, we took it in there and we hung that thing for days, figuring out how to do this.
Wow.
And they could actually take, a person could push it and make it rotate, but they ended up using the overhead crane.
Look how small the ET looks down there to give you a
Yeah.
dimension size of the
Yeah.
VAB in there. That's
The VAB is a
interesting.
huge building. This is not Columbia, but what I wanted to show here is when we opened the doors out at the pad, we used these things called torque tubes, and you see them are really lightweight. They expand across the 4 panels, and the reason why we have to use those is because they're 4 independent panels, and all that holds them together is a pin. So that each panel could slide, expand, and contract as they go through the launch environment. And so if we didn't have those on there, because they were just independent of each other, they would actually sag down and cause a jamming. So we put a torque tube to react that so it holds them up in the proper position. And they normally are put on out at the pad. We have put them on in the OPF sometimes. This is a sad part here that I'm going to talk about. This is Columbia. This is right after the countdown demonstration test that we do. And the aft fuselage during that thing is we load the fuels up because we're going to launch, and we're going to simulate a launch, except we just don't hit T0. They purge that aft compartment with nitrogen to keep from having a fire started. So after the flight readiness review is over, they can switch over to normal atmospheric air in there. And the test conductor was told that that had been completed when actually it was still full of nitrogen. Let's go to the next deal. And these 3 gentlemen I have worked with, I can't remember the exact names of each individual. I just know who they were. And one of them was John Burasat. Forrest Cole was the other one. And then the last one is Nick Mullanes. And these gentlemen, the first one went in, took 2 steps, and 2 breaths is all you get, and he hit the deck. The second one went in after to rescue him, and he succumbed to the nitrogen. And the third one started to go in, got in just a little ways when somebody pulled him back out. Now, John Burasat died in the ambulance going to the hospital, and then Forrest Cole died 1 day later in the hospital from the starvation of nitrogen, oxygen. And Nick Mullane died in 1995 from complications from that event. So those were the 3.
God bless them. We honor them out of Spaceview Park on our special pylon that has people.
I wish I actually knew their name. I worked around them. We have so many techs, and I just never caught all their names. I know they were there. I've seen them work, but I didn't actually talk to them. But I do recognize those gentlemen.
Nice memory of a tragic day at the Space Center there.
Yeah. And this is just the last slide. This just shows the inclinations that we launched the shuttles from. 28 degrees was what the STS-1 did. And then we have the 38 degrees. And then we have for the ISS is 51.6 degrees latitude. And then 57 was the highest we flew. Technically, that's what we advertised, but we actually did fly 59 on one of the DoD missions.
And of course, we just had the Fram 2 go 90 degrees.
90 degrees, yeah.
Incredible in there.
And this is STS-2. And this is something that they don't talk about, but we flew this is called Surrey A antenna, and a Surrey B was flown on another mission. And this is a ground penetrating radar, and it could penetrate down, I think, to 3 feet into the Earth's surfaces. And it mapped on the 28 degree inclination that they flew, they mapped the whole Earth 3D penetrating into the soil. And they found a few things. They found some where oil was. They found some stuff, ruins that were buried in the desert they didn't know about, stuff like that.
STS-2 with
STS-2.
Richard Truly in the pilot seat, and Joe Engel in the commander seat.
I have an autograph from Joe Engel, by the way.
That was
and this is Surrey antenna B that was flown.
Is that
This-
a person up there inside of there?
No. There's no person up
Oh,
there.
okay. I was like a
Yeah.
person crouched over
Yeah,
there.
there's a couple people. One of the guys may be me. That's my typical stance with my arms crossed over, and that would have been my co-part there, which would be Don Shufflinger.
Okay. Well, Gary, thank you for another exemplary show here, taking us behind the scenes. Some of you watching today: Nick Sedler, Neil 1030, Forward Omni, Cliff Watson in Australia, my daughter Jessie Q with my granddaughters. Elena is watching. Michael Bruno, good questions from Michael. Doug Forrest, we'll see him this weekend. The
Okay.
Shuttle Fest. Tom Celentano, Gary Gerald, Carlton Bailey, Dean Babcock, Julie Clay, Tom Usiak, Mitch Rothman of Man Space, Steve Jokums, Bob Mayran, Mark Fell, and Dave Stange, all enjoying today's show. And hope that those of you like Connie McDaniel and maybe Hazel Banks not chiming in, and hope that you all enjoy Gary as usual. He's probably going to do 2 more shows for us before he goes back to summer in Georgia,
Yeah.
up there with your wonderful wife. What you going to talk about next for us, Carrie?
Well, it'll be Apollo 13, and it'll be a little bit more detailed than what you've seen in the movies, and I feel put some fillers in there.
Yeah,
And for once, I'm going to talk about electronics.
electronics.
Yeah,
Okay.
yeah, I'm going to talk about electronics. And
All right.
a little
Well,
bit of
that's
cryo.
the joke because Gary knows everything
Yeah.
that electronics or fluids aren't flowing through on a shuttle or an Apollo. And then before you leave us for the summer, and we will miss you as a docent.
Yeah.
He's an outstanding docent twice a week here on Tuesdays and Thursdays. You got another program you
And
want
we'll
to
be
share?
talking about the payloads, and it's quite interesting in how they had to overcome quite a few problems with the shuttle expanding, contracting as either through the launch environment or as they go around from sun to back to the dark side, and how the engineers had to overcome how the orbiter expands and contracts, and they also had to have the capability where we could not damage the payload because of that, and also the payload could not damage the orbiter. And we will talk about a time where the payload did actually damage the orbiter.
A super close call that Gary's
Very-
told me
very
about
close
several
call,
times. This
yeah.
was another dodged a bullet
Yes.
from some pyrotechnics in the
In the shuttle bay.
Shuttle bay
And
that
then
went awry.
in processing and putting one in at the orbiter. In fact, the Challenger, the first time we let's see, that was Challenger. The first flow launch was an IUS Tidris and another deployable payload, and we came close to killing everybody out there that day.
Well, you saw all those wires and pipes and everything
Yeah.
that are unexposed. Imagine severing some of those and
Well, that
not
was
being able to
when- that
control
was-
the vehicle.
That was
so.
the later one that we launched, the TOS satellite. But anyway, for Challenger, we could have taken out the whole pad and killed everybody there that day.
You'll learn more about that later in the month of April, as we'll have Gary back next week and then probably the following week on there, Gary. So appreciate you very much. Bruno says interesting show, and we're actually very grateful for all of you watching today. Great sticking with us on a 90-minute program here, but why not? Because you're hearing from an expert, and that's what the American Space Museum is all about. And Stay Curious is bringing you experts in the space industry to share with you their knowledge and answer your questions. So Gary, awesome job today,
thank
my
you.
friend, and appreciate everybody out there. Marty, we have anything to button up over there that before we say goodbye?
Just some good comments like you mentioned before. You can read them offline. And we did get a hey mark from Terry Yvette Green.
Thank you very much. And we'll appreciate y'all watching today. Remember, we're not going to have a program on Friday, but we will tomorrow and Thursday. Thursday will be a mosh pit here of just people coming in for the weekend, and we'll put people like Chris Calley and Mitch Rothman, and we'll have many of you that are in here. I was trying to think a couple off the top of my head, but you know who you are, so we can't wait to have a good time with you all.
Yeah.
So until then, I'm Mark Marquette saying I can't wait to all see you all in the American Space Museum to bridge the space between us. Thank you so much.